This video contains flashing lights and is not suitable for viewers who suffer from brontophobia. Viewer discretion advised.
The weather changes daily. Watch it long enough, and you might witness some of the most amazing weather phenomenon.
Our atmosphere shows off so many strange and wondrous displays. But oftentimes, these brilliant phenomena happen so rarely and in so many widespread places across the world that they're almost never seen.
From cloud formations and thunderstorms to sun illuminations and rainbows, we've covered them all in the Top 40 Amazing Weather Phenomenon.
Waterspouts and snowspouts. Waterspouts look like mini tornadoes made of water, and they are always located below a cloud and above a body of water. While they seem to suck up liquid from the water they are located above, they are actually made of water droplets formed by condensation. Stronger waterspouts are usually quite dangerous, posing threats to ships, planes, helicopters, and swimmers. It is recommended to keep a considerable distance from these phenomena and to always be on alert through weather reports. An extremely rare occasion is a snowspout, which is a waterspout forming under the base of a snow squall. Very little is known about this phenomenon, but it has been captured on video.
Morning glory clouds. The morning glory clouds are a rare meteorological phenomenon, occasionally observed in different locations around the world. The southern part of northern Australia's Gulf of Carpentaria is the only known location where it can actually be predicted and observed on a more or less regular basis. They can stretch over 1,000 kilometers long and occur at altitudes of up to 2 kilometers. The morning glory is often accompanied by sudden wind squalls, intense low-level wind shear, a rapid increase in the vertical displacement of air parcels, and a sharp pressure jump at the surface. In the front of the cloud, there is a strong vertical motion that transports air up through the cloud and creates the rolling appearance, while the air in the middle and rear of the cloud becomes turbulent and sinks. These tubes and the surrounding air can cause dangerous turbulence for planes when near. Morning glory clouds are not to be confused, however, with roll clouds. Green flash. This phenomenon usually occurs during sunrise or sunset, when more of the light reaches the observer without being scattered first. The green of the flash is caused by light being bent and refracting back into the atmosphere. The atmosphere acts as a prism of sorts, separating light into various colors. When the sun fully rises above the horizon, the different colors of the spectrum overlap, causing the spectrum to be invisible to the naked eye. It's called a flash because that is exactly what it is. The green is only visible for a few flashes for a few seconds at a time.
Haboob. The haboob is a strong sandstorm and is often associated with thunderstorms and even small tornadoes. A haboob usually lasts about 3 hours and are strongest in April and May, but occur in every month except November. When this downdraft or downburst reaches the ground, dry, loose sand from the desert settings is essentially blown up, creating a wall of sediment preceding the storm cloud. This wall of sand can be up to 100 kilometers wide and several kilometers in elevation. At their strongest, haboob winds can travel at 20 to 30 miles per hour, and they may approach with little to no warning. In North America, sandstorm walls associated with severe thunderstorms are also called haboobs. They are often caused by the gust front of cold air from supercell thunderstorms and are especially frequent in Arizona and Texas with wind speeds around 30 to even 50 miles per hour.
Dust devils. Dust devils are usually harmless tornadoes that pick up dirt and dust, but can, on rare occasions, grow large enough to pose a threat to both people and property. Dust devils form when hot air near the surface rises quickly through a small pocket of cooler, low-pressure air above it. If conditions are just right, the air may begin to rotate. As the air rapidly rises, the column of hot air is stretched vertically, causing intensification of the spinning effect by conservation of angular momentum. They're comparable to tornadoes in the fact that they are both a weather phenomenon of vertically oriented rotating columns of air. Most tornadoes are associated with a larger parent circulation, the mesocyclone on the back of a supercell thunderstorm. Dust devils form as a swirling updraft under sunny conditions during fair weather, rarely coming close to the intensity of a regular tornado. Most dust devils are very small and weak, often less than 3 feet in diameter.
Belt of Venus. The Belt of Venus is a phenomenon that occurs during dusty evenings, just before sunrise or after sunset. Part of the atmosphere above the horizon appears slightly off-color, slightly pink or orange. This off-color band between the dark eclipse sky and the blue sky can be seen in nearly every direction, including that opposite of the sun. The Belt of Venus can be seen from any location with a clear horizon. The Belt of Venus is seen in many panoramic photoshoots and landscape photos. The subtle changes in dusk and dawn sky are marvelous, but this phenomenon, the Belt of Venus, is particularly subtle because most people like to see the sunset or sunrise and rarely turn around to look at the other horizon. Next time you get a chance, look and you'll be pleasantly surprised, particularly if you witness it at full moon with crystal clear horizon. Sun shower. A sun shower is a phenomenon in which rain falls while the sun is shining. Sun showers are viewed as harbingers of true storms to come, indicating that a storm will occur at the same time in the next few days. Sun showers are often known to create one or more rainbows, although a rainbow can only appear when the sun is at a low enough angle, which is generally in the morning or late evening. Additionally, the phenomenon has a wide range of sometimes remarkably similar folkloric names and culture around the world. A common theme is that of trickster animals, the devil, getting married, and even good luck, although many variations of parts of this theme exist.
Fog bow. There are various different names for fog bows, such as sea dogs, cloud bows, or white rainbows. Like a normal rainbow, a fog bow is created with the diffraction of light through water droplets. But, in the case of fog bows, very small water droplets create the effect. In a fog bow, the water droplets in the mist are too small to refract and reflect light, meaning the arc appears to be white, although some can feature weaker colors. A fog bow can occur anywhere that thin fog is masking fairly bright sunshine. So, the phenomenon is most likely to emerge when the rising sun is less than halfway toward midday.
Fall streak hole cloud. A fall streak hole cloud, or hole punch hole cloud,
is a large circular or elliptical gap that can appear in a cirrocumulus or altocumulus clouds. Such holes are formed when the water temperature in the clouds is below freezing, but the water has not frozen yet due to the lack of ice nucleation particles. When ice crystals do form, it will set off a domino effect due to the Bergson process, causing the water droplets around the crystals to evaporate. This leaves a large, often circular, hole in the cloud. Fall-streak hole clouds have been spotted around the world recently. The main sightings have been in Romania, Moscow, Malta, and Florida. Other theories as to the creation or forces that form fall-streak hole clouds range from them being UFO clouds, crop circle clouds, or also the product of government technology such as HAARP.
Sun halos. Like rainbows, sun halos are formed around the sun due to the moisture being refracted from the sun's rays in the upper atmosphere. Halos around the sun happen when high, thin, cirrus clouds are drifting high above. Tiny ice crystals in the Earth's atmosphere cause the halos. They do this by refracting and reflecting the light. Sometimes, two or more areas of the circle or arc surrounding the sun will be brighter, forming what are called sundogs. Halos can also form around the moon, and occasionally around the brighter stars and planets like Venus. The colors of a halo can differ, like a rainbow, depending on how it is dispersed after reflection and refraction. Double rainbow. A double rainbow is a very rare weather phenomenon caused by double reflection of sunlight inside the raindrops and appears at an angle of 50 degrees to 53 degrees. The second and more faint rainbow is called the secondary rainbow. It occurs when refracted light does not escape the raindrop after being reflected the first time. Instead, the reflected light reflects off the raindrop surface a second time as well, producing a secondary rainbow with its colors reversed compared to the primary rainbow. Unfortunately, fewer light rays are available to undergo the additional refraction process, so the resulting secondary rainbows appear less vivid and faint. Triple and even quadruple rainbows are possible, depending on how many times refracted light is reflected within a rainbow. Light pillars. Light pillars, or light poles, is an atmospheric phenomenon and can be seen at night over the large cities with different colored lights. They can only be seen during very cold weather at -20 degrees Celsius or lower. The pillars are not physically over the lights or anywhere else in space for that matter. Like all halos, they are purely collected light beams from all the millions of crystals which just happen to be reflecting light towards your eyes or the camera. Artificial light pillars can be much taller than their natural counterparts because rays from the lights are not parallel and plate crystals with small tilts can still reflect them downward. The higher the crystals in the atmosphere, the taller the pillar. When the crystals are very high or the light sources are close, the pillars seem to radiate from overhead.
Mammatus clouds. These odd-shaped clouds are often associated with a storm front, especially one involving a thunderstorm. It's not completely understood how they form. True to their ominous appearance, mammatus clouds are often harbingers of a coming storm or other extreme weather system. Typically composed primarily of ice, they can extend for hundreds of miles in each direction, and individual formations can remain visibly static for 10 to 15 minutes at a time. While they may appear foreboding, they are merely the messengers before or even after severe weather. Novia-Zimla effect. The Novia-Zimla effect is a polar mirage caused by high refraction of sunlight between atmospheric thermoclines. The Novia-Zimla effect will give the impression that the sun is rising earlier than it should, and depending on the meteorological situation, the effect will present the sun as a line or a square made up of flattened hourglass shapes. Light refracted through atmospheric temperature inversions can cause images of objects below the horizon to rise up into view. This phenomenon is called looming. The Novia-Zimla effect occurs in Arctic regions where tracts of cold air remain uniquely stable over hundreds of kilometers, creating a special instance of a meteorological temperature inversion. The distortion, powerful enough to bend light through 4 or 5 degrees, can make celestial bodies like the sun or moon appear wholly above the horizon when they are physically below it.
Mirages. Mirages occur when light is refracted to produce an image of an object or the sky where it simply isn't. A mirage is usually most noticeable on hot and sunny days. The most common kind is one where it appears that there is a pool. However, when you get close to it, you realize that it just simply is not there. Warm air is less dense than cool air, and the variation between the hot air at the surface of the road and the denser cool air above it creates a gradient in the refractive index of the air. Objects that attempt to enter the mirage will appear to melt or disappear completely. However, in reality, they don't. They're unaffected. Roll cloud. Roll clouds can be hundreds of kilometers long, and just as the name suggests, they roll. This is because of cold air rushing out of a downdraft from a storm front, lifting warm air which cools and sometimes forms this type of cloud. Roll clouds have been seen over coastal areas such as California, the English Channel, Shetland Islands, eastern Russia, and other maritime regions of Australia. Now, depending on the conditions, a roll cloud can last for several hours and extend for several hundred miles. The roll cloud will appear to be slowly rolling about its horizontal axis. However, it does not produce tornadoes, as intimidating as it looks.
Sun pillars. Sun pillars are a halo phenomenon of a vertical shaft of light extending upward or downward from the sun. Typically seen during the sunrise or sunset, sun pillars form when sunlight reflects off the surfaces of ice crystals associated with thin, high-level clouds. The hexagonal plate-like ice crystals fall with a horizontal orientation, gently rocking from side to side as they fall. When the sun is low on the horizon, an area of brightness appears in the sky above or below the sun, as sunlight is reflected off the surfaces of these tipped ice crystals. Sun pillars are seen best within a few minutes of sunrise or sunset. Initially, they have about the same color and width as the sun. But sun pillars will gradually change their color from orange-white to red-orange.
Noctilucent clouds. Noctilucent clouds are atmospherically high clouds that refract light at dusk when the sun is already set, illuminating the sky with no seeming light source. The clouds are seasonal, so they are only seen from mid-May to mid-August. Noctilucent clouds become visible about the same time as the brightest stars are usually bluish or silvery, but sometimes orange or reddish. They most closely resemble thin, streaky cirrus clouds and are thought to be made of ice crystals. Noctilucent clouds are the highest cloud in Earth's atmosphere, forming above 200,000 feet. They are typically faint, but occasionally become visible during twilight when the sun is below the horizon. and the clouds become illuminated. No one's quite sure why they form, and indeed they weren't seen before 1885, and so there is some suggestion that they are linked with man-made climate change.
Red moon and blue moon. Due to different atmospheric issues, the moon will occasionally appear tinged with a color. This can be caused by excess smoke or dust, or even eclipses. This could all play into the effect that makes the moon appear to change color. Red moons, which can usually be caused by dust particles or lunar eclipses, are much more common than blue moons. Blue-colored moons do occur, but very rarely, when dust or smoke particles in the air are of a very specific size. Such particles help create a blue-colored moon by scattering blue light. The phrase, "once in a blue moon," is colloquially used to suggest that something is very rare. The more you know.
Sundog. Sundogs are an atmospheric optical phenomenon that creates bright spots of light in the sky, often on an luminous ring or halo on either side of the sun, primarily associated with the reflection or refraction of sunlight by small ice crystals making up cirrus or cirrostratus clouds. As the sun rises higher, the rays passing through the crystals are increasingly skewed from the horizontal plane. Their angle of deviation increases and the sundogs move further from the sun. However, they always stay at the same elevation as the sun. Sundogs are the second most frequent halo phenomena behind the sun halo. The difference between a sundog and a sun halo is the orientation of the ice crystals through which sunlight passes before reaching our eyes. There are also moondogs that appear alongside the moon, and are formed by lunar light passing through the ice crystals.
Anti-crepuscular rays. You might describe these sun rays as God rays in a particular formation. They are formed at either sunrise or sunset, when the sun casts rays up from the horizon through some well-placed clouds. They are similar to crepuscular rays, being caused by clouds in front of the sun. But the essential difference is, crepuscular rays seem to converge on the sun, while anti-crepuscular rays converge in the opposite direction, and you must be facing away from the sun to see them. Anti-crepuscular rays appear to be converging on a point known as the anti-solar point, but in fact, this is an illusion. They are parallel rays of light, and what you are looking at is akin to a very long straight road with a vanishing point in the very far distance.
Lenticular clouds. These clouds aren't always shaped like alien spaceships from the 50s sci-fi movies, but sometimes rather like a stack of lens shapes, or even just a particularly long cloud. These rare formations, known as lenticular clouds, have been mistaken for UFOs thanks to their smooth, flying saucer-like shape and orange glow. Lenticular clouds are formed through air moisture that condenses from an updraft that has been interrupted by a mountain or other large formation and has come back down. Now, after all of this air moisture condenses and forms a cloud, it evaporates again, leaving behind this lens-shaped cloud formation that you see.
Mesocyclone. Mesocyclones are cyclonic turning patterns in thunderstorms that often lead to tornadoes, and sometimes spawn dozens of tornadoes in a short amount of time. They are called cyclones because of the rotating storm system. A mesocyclone will typically develop at the mid-levels of a tematic storm, and build down to lower levels as the storm matures. A storm scale region of rotation, around 3 to 10 kilometers in diameter, is often found in the left rear flank of a supercell. The circulation of a mesocyclone covers an area much larger than the tornado that may develop within it. They are caused by large, long-lasting, rotating updrafts that form in strong thunderstorms, though they are not as large as supercells. Supercell thunderstorm. It's the name given to a continuously rotating updraft deep within a severe thunderstorm that looks downright scary. Supercell thunderstorms are amongst the most dangerous thunderstorms that occur on the planet, and almost always produce severe weather of one kind or another. Supercells have the capability to produce tornadoes, damaging hail, and strong downdrafts. Most tornadoes are spawned from a supercell. There are also a variety of supercell types, including classic, high precipitation, low precipitation, and even miniature. Supercells are formed everywhere severe weather occurs, provided there's enough wind shear and instability in the atmosphere. They're most common in the middle of the United States, but they can occur in 49 of the 50 states, as well as Canada and elsewhere around the world.
Glory. Glory is an atmospheric optical phenomenon consisting of a series of concentric colored rings about the antisolar point visible against the background of a cloud, fog bank, or mist. Glories aren't as rare as you might think. In fact, they're quite often seen by passengers as an aircraft moves between the clouds and the sun. Only passengers on the side of an aircraft looking away from the sun can see them, however. If you have a strong light source at your back and you're looking into the clouds or fog, then it's possible to see the shadow of the aircraft you're traveling on surrounded by a glory. This optical phenomena results from the diffraction, in this case, the backscattering of light by small droplets of water. The radius of the glory is dependent on the size of the drops. The smaller the drops, the bigger the glory.
Undulatus asperatus. These ominous-looking clouds are particularly common in the wide-open plains states region of the U.S. Seen often during the morning or midday hours following convective thunderstorm activity, these clouds are considered a precursor to severe weather, appearing to form rain or thunderstorms. Regardless of official cloud status or not, Undulatus asperatus are strikingly visual reminders that the atmosphere is an ocean of gas, complete with cloud waves crashing high above. They occur when enough atmospheric instability, or rising air, is available to create widespread cloud cover, as well as wind shear and turbulence, which creates this wavy, rough, sea-like effect.
Thundersnow. Thundersnow is a strange weather phenomenon first discussed in the winter of 2006, involving a thunderstorm with snow instead of rain. Thundersnows require very strong upward vertical air movement within winter storms, usually associated with highly baroclinic low-pressure systems with a source of warmer air wrapping into the storm. The warmer air ingested into the system helps to introduce instability into the cold sector of the storm, which, along with the ambient upward vertical motion, can produce prolific lightning activity. Thundersnow is typically associated with very heavy rates of snow, which can lead to reduced visibility, so be careful out there. St. Elmo's Fire. This weather phenomenon is not actually fire at all. Instead, it's the result of a gap in electrical charge giving the illusion of a burning flame atop a sharp object, like lightning rods, masts, spires, and chimneys, or on aircraft wings. St. Elmo's Fire can also appear on leaves, grass, and even at the tips of cattle horns. Because this phenomenon was so regularly observed by sailors during thunderstorms, it was named after the patron saint of sailors, St. Elmo. The flames associated with St. Elmo's Fire are not red like fire flames, but rather shades of blue or violet.
Moonbows. Moonbows are created by light reflected from the moon. These very rare sightings of nighttime rainbows or lunar rainbows are associated with moisture and post-rain conditions, very similar to regular rainbows. Unlike rainbows, no sunlight is associated with moonbows. People who have witnessed moonbows should consider themselves very lucky, as the atmospheric and moon conditions need to be just perfect. A full or almost full moon at low level combined with moisture droplets. Moonbow hunters are more likely to find these rare bows at major waterfalls, including the Cumberland Falls.
Kelvin-Helmholtz clouds. This formation is very unusual and a bit surreal. These tremendous cloud formations are the result of shearing winds up at the cloud level. A particular type of turbulence can develop in a layer of cirrus cloud, which forms below an inversion between air currents of differing speeds or directions. Sea waves break as their bases are slowed down upon reaching shallow water, and their crests surge ahead. Cloud waves break in the same way. When their crests are pushed ahead of their troughs by the difference in air currents, they are also rarely observed as they don't retain the shape for very long. The clouds often form on windy days, where there is a difference in densities of the air, such as in a temperature inversion.
Volcanic lightning. Volcanic lightning, or dirty thunderstorms, is a weather phenomenon that is related to the production of lightning in a volcanic plume. The process starts when particles separate, either after a collision or when a larger particle breaks in two. Some difference in the aerodynamics of these particles then causes the positively charged particles to separate from the negatively charged particles. Lightning occurs when this charge separation becomes too great for air to resist the flow of electricity. Volcanic eruptions also release large amounts of water, which can also help these thunderstorms along. Catatumbo lightning. Catatumbo lightning is an atmospheric phenomenon in Venezuela. It occurs only over the mouth of the Catatumbo River, where it empties can occur in areas like northwest Venezuela. When warm and cold fronts meet, it forms the right conditions for this lightning. The frequent, powerful flashes of lightning over this relatively small area are considered to be the world's largest single generator of tropospheric ozone. It originates from a mass of storm clouds at a height of more than 5 kilometers and occurs during 140 to 160 nights a year, 10 hours per day, and up to 280 times per hour. But not only that, but nearby marshes emit methane gas, improving the electrical conductivity of the clouds, which helps cause these extended lightning strikes.
Fire rainbows. This list is home to some pretty cool stuff, but this is one of my favorites. A fire rainbow, rainbow cloud, or circumhorizontal arc is an extremely rare phenomenon that occurs only when the sun is high, allowing its light to pass through high-altitude cirrus clouds that have a high content of ice crystals. Fire rainbows, unlike what their name implies, are neither fire nor rainbows, but are called this because of their brilliant and beautiful pastel colors and flame-like appearance. Brightly colored circumhorizontal arcs occur mostly during the summer and between particular latitudes. When the sun is very high in the sky, sunlight entering flat, hexagon-shaped ice crystals gets split into individual colors like a prism. The conditions required to form a fire rainbow are very precise. The sun has to be at an elevation of 58 degrees or greater. There must be high-altitude cirrus clouds with plate-shaped ice crystals, and sunlight has to enter these said ice crystals at a very specific angle. This is why these are such a rare sight. The rarity in the arc depends on where you are. At medium latitudes, like much of the US, it's not rare, and can be seen several times each summer, if you're lucky, of course. In contrast, further north, in much of Europe, the circumhorizon arc is a rarity, and impossible to see north of Copenhagen. Fire rainbows are not to be confused with iridescent clouds, which can produce a similar effect. While circumhorizontal arcs occur only in cirrus clouds, iridescence often occurs in altocumulus, cirrocumulus, and lenticular clouds, and it's very, very rare to see them in cirrus clouds.
Red rain. Red rain is caused by dust or sand that has blown into the atmosphere and is carried by the wind to great distances, eventually mixed with rain clouds, and gives color to the rain itself. A number of theories spread about the cause of the colored rain, including its relation to aliens, before an official report concluded that the colors were caused by the algae spores sucked into the atmosphere by a waterspout. There are a number of algae species in the region, which could explain why the stories were so constant for the last 100 years. Red rain in Europe, and especially England, is usually colored by the dust that is carried across the continent coming from Saharan sandstorms. Two suns. If the sun is really close to the horizon and there are cirrus clouds in the sky, sometimes another sun or light source can appear, thus giving the impression of another sun appearing together in the sky. Two suns are actually the color of bright points of light created by the sun that was deflected by the crystals in high clouds. Two suns have been reported in many different parts of the world, sometimes being close together and other times far apart. As of today, scientists are still puzzled with the phenomenon, and it's still not completely clear how it's formed.
Fire whirl. A fire whirl, also known as a fire tornado or fire devil, is a rare phenomenon in which fire forms a tornado-like vortex of flames. Fire whirls can be spawned by other natural events, such as earthquakes and thunderstorms, and can be incredibly dangerous, in some cases spinning well out of the zone of the fire itself. Fire whirls are more closely related to dust devils and are distinct from the larger, more powerful tornadoes that develop from supercell thunderstorms. Fire whirls have been known to be nearly a mile high, have wind speeds of over 100 miles per hour, and to last for 20 or more minutes. Although it's rare, this type of weather is extremely dangerous.
red sprites and blue jets. We've talked about some pretty weird and beautiful things thus far, but this is where things start to take a turn for the bizarre. Red sprites and blue jets all refer to phenomena that occur in the upper atmosphere in the regions around thunderstorms. They appear as cones, glows, and discharges. They were only discovered in the last century because of their placement and extremely brief lifespan. Red sprites are massive but weak luminous flashes that appear directly above an active thunderstorm system and are coincident with cloud-to-ground or intra-cloud lightning strokes. They're normally colored a reddish-orange, with hanging tendrils below and arcing branches above. They can also be preceded by a reddish halo. Sprites rarely appear singly, usually occurring in clusters of 2, 3, or more. Blue jets are a second high-altitude optical phenomenon. Distinct from sprites, observed above thunderstorms using low-light television systems. As their name implies, blue jets are optical ejections from the top of the electrically active core regions of thunderstorms. From what we know, red sprites and blue jets are an integral feature of every thunderstorm system of moderate size or larger in the terrestrial system, and may be an essential element of the Earth's electrical circuit. Furthermore, it seems likely that they have been a part of thunderstorms dating back millions of years. It also seems possible that red sprites and blue jets occur with the lightning on other planets such as Jupiter and Venus.
Earthquake lights. Earthquake lights are unusual luminous atmospheric phenomenon. They are usually reportedly in areas of high seismic activity or volcanic eruptions. They were believed to be myths until they were photographed in 1965 during an earthquake in Japan. Since then, many mysterious lights have been witnessed and filmed before seismic occurrences. It was then that seismologists worldwide accepted their existence as earthquake lights. Over the past few years, various theories have been proposed for how earthquake lights form, including the disruption of the Earth's magnetic fields by tectonic stress, in which quartz-bearing rocks produce voltages when compressed in a certain way. Earthquake lights seem to be most common in Italy, Greece, France, Germany, and parts of South America, though they have been observed in Japan, North America, and elsewhere. The lights can occur weeks before major earthquakes or during the actual shaking. They have been recorded at distances of up to 100 miles from the epicenter. Ball lightning. This is a very rare phenomenon that involves ball-shaped lightning that moves much slower than normal lightning. It has been reported to be as large as 8 feet in diameter and can cause great damage. There are reports of ball lightning destroying whole buildings. There currently is no fully satisfactory or generally accepted scientific theory for ball lightning, mainly because it is so rare, and when it does occur, it doesn't stay around long enough to be studied. It generally has a lifetime of less than 5 seconds. At one time, ball lightning was thought to be extremely rare, but this was because most eyewitnesses feared ridicule and wouldn't come forward. In reality, 5% of the population has seen ball lightning. Today, most researchers agree that it is real, yet its nature is still highly controversial, and no sensible theories yet exist to explain it. Ball lightning has been reported as glowing orbs in the sky, which is sometimes mistaken as UFOs.
Aurora Borealis. The aurora borealis are a fascinating phenomenon caused by collisions between the sun's electrically charged particles and the molecules and atoms in the Earth's atmosphere. The spectacular light show takes place in the upper atmosphere at a height of approximately 100 kilometers and can best be compared to candles flickering in the wind or fluttering curtains in shades of green and yellow. They are more typically seen closer to the poles and during the equinoxes of the year. The phenomenon is often seen around midnight and is experienced on a dark, clear night in the period from September to the beginning of April. Most famous of these are the Northern Lights.